Okay, next we're going to be looking at inverse proportion. So these questions are the same sort of abstract nature as the previous one, with a very subtle difference. So in this question we have that S is inversely proportional to R. Inversely proportional, you may remember this from year 9, but inversely proportional means as one thing goes up, the other goes down. So for example, if you have workmen building a wall, as you increase the number of workmen, the time it will take to build the wall will decrease. Okay? So that's what inversely proportional means. As one goes up, the other will go down. So, this question carries on. It says, when S is equal to 100, R is equal to 20. Okay, so that's all we get. S is inversely proportional to R, so when S is 100, R is 20. So part A says, find S when R is equal to 2. Okay? And B says, find R when S is equal to 6.4. So here's the groundwork. Here's how we start for an inverse proportional question. We say that instead of writing S is inversely proportional to R with some funny new symbol, we use the same symbol as before. We say S is proportional to 1 over R. So writing S is proportional to 1 over R is the same as saying that S is inversely proportional to R. So when you see the word inversely proportional, this is how you turn it into a mathematical statement. From here we replace the fish symbol by is equal to k, so it's S is equal to k times by 1 over R. So if I were to write S is equal to k times by 1 over R, which is what we would have done before, that's the same as saying, well, S is equal to k divided by R. Okay? From here, well, I know that S is 100 when R is equal to 20. So if I replace those, S is equal to 100 and R is equal to 20, then I can say, well, K is equal to 100 times 20, which is equal to 2,000. Good. So my new equation, my original equation, can become S is equal to 2,000 divided by R. And I'm going to use this to answer parts A and B. Once you know K, the question becomes fairly straightforward. So for A, we know that R is equal to 2. So we can say that S is equal to 2,000 divided by 2. 2,000 divided by 2 is 1,000. Lovely. Part B. S is equal to 2,000 divided by R. So when S is equal to 6.4, we have 6.4 is equal to 2,000 divided by R. Maybe you should pause the video now and see if you can just find out what R is. So if you're following through here, in this equation, you would say, well, 6.4 times by R is equal to 2,000, possibly, because we don't like the fact that R is on the denominator, so we can times both sides by R. Okay, once you times both sides by R, to find R, you would divide by 6.4, and 2,000 divided by 6.4 is equal to 312.5. So, when S is equal to 6.4, R is equal to 312.5. You can see how abstract this question is. We don't know what S is, we don't know what R really means. All we're told is that they're inversely proportional to each other. Okay, so just quickly before we go, maybe you could think about what you would write if I were to say that, I don't know, let's say T is inversely proportional to x squared. How would this look as a statement? Well, this would look like as a statement, if you haven't paused it and thought about it yourself, pause it now, but this should look like T is proportional to 1 over x squared, and then I would write this as T is equal to K times by 1 over x squared, which you could say is just K over x squared. Okay, so this is how you turn a statement like this into a piece of mathematical writing, a mathematical equation. Okay, thanks for watching. That's pretty much all you need to know about direct and inverse proportion. From Tuesday's lesson onwards, we'll be doing some practice of this, and that will be us covered for the half term. You'll do some revision over half term, and then there'll be tests at the start of November. Thanks for watching.